China's shadow AI cloud is not a future threat, it is operational. The question of whether export controls could contain China's AI development has already been answered, and the answer is no. When the United States restricted access to Nvidia's most advanced chips beginning in 2022, the stated logic was containment. Limit the hardware, limit the capability, buy time. That logic assumed China would absorb the constraint and wait. Instead, Chinese firms and state-adjacent entities spent that time building something the controls were never designed to address, a geographically distributed compute network that sits outside American jurisdiction entirely. The mechanism is not complicated. Chinese cloud providers, Alibaba Cloud, Huawei Cloud, and a cluster of smaller operators expanded their infrastructure footprint into countries that face no American export restrictions: Malaysia, the United Arab Emirates, Kazakhstan, Saudi Arabia. In each case, the pattern is the same: a data center agreement, a local partnership, and a facility that can legally acquire the chips Washington restricted from Chinese soil. The compute then becomes accessible remotely, routed back to users who could not have purchased the hardware directly. This is not a loophole in the traditional sense. A loophole implies an oversight, something the drafters missed. What happened here is structurally different. The controls were written to govern hardware at the point of sale. They were not written to govern services. Once the chips are legally installed in a facility in Abu Dhabi or Kuala Lumpur, they can serve AI workloads for clients anywhere in the world. The restriction on the object does not extend to the output of the object. The export control architecture assumed a hardware-centric model of AI development. That capability is bounded by physical possession of chips. That assumption was already weakening when the first restrictions were written. Cloud computing had spent 2 decades demonstrating that physical possession and functional access are not the same thing. The policy did not fully account for that gap. What closed the gap was speed. Between 2022 and 2024, Chinese cloud operators moved faster into third-country markets than American regulators moved to close the service layer exposure. By the time the Commerce Department began issuing guidance on cloud service access, the so-called Know Your Customer requirements for cloud providers, the infrastructure was already in place. Retrofitting controls onto an operational network is a different problem than preventing one from being built. The unique angle here is not that China found a workaround. Countries find workarounds. The angle is what the workaround produced. A distributed, multi-jurisdiction AI compute network is harder to sanction than a domestic one. It has more legal surface area, more political relationships protecting it, and more plausible deniability at every node. The export controls did not just fail to contain Chinese AI development, they incentivized the construction of an infrastructure that is specifically resistant to future containment efforts. That outcome was not accidental in the way policy failures usually are. It was the predictable result of applying hardware controls to a software-defined industry. The chip is not the capability anymore. The training run is the capability. The model weights are the capability. And neither of those things is a physical object that clears customs. Washington understood this at some level. The subsequent rounds of restrictions tried to address it, expanding controls to cover chip architectures, adding foreign direct product rules, pressuring allied governments to align their own export policies. Each round was more sophisticated than the last. Each round also arrived after the Chinese operators had already adapted to the previous one. The infrastructure that exists today was built in the space between rounds. The mechanics of this network are worth tracing precisely because the political response to it depends entirely on whether policymakers understand what they are actually looking at. A data center in Malaysia that runs Nvidia H100s, chips that cannot be shipped directly to a Chinese entity, is not on its face a sanctions violation. The Malaysian operator acquired the hardware legally. The facility is staffed locally. The power agreements, the land permits, the employment, all of it sits inside Malaysian jurisdiction. From a compliance standpoint, the transaction is clean at every documented step. What makes it structurally useful to Chinese AI development is the service layer sitting on top of it. Cloud compute is sold as API access. A researcher in Shanghai, a model training operation in Shenzhen, a state-affiliated lab in Beijing, any of them can purchase compute time from a facility in Kuala Lumpur the same way an American startup purchases time from AWS. The geographic separation between the hardware and the user is the entire architecture. It is not incidental to how this works. It is how it was designed to work. Alibaba Cloud's international expansion during this period is the clearest example. Between 2022 and 2025, the company opened or announced data center regions across Southeast Asia, the Middle East, and Central Asia at a pace that substantially exceeded its pre-restriction expansion rate. Some of that growth reflects genuine commercial demand in those markets. But the correlation between the timing of American chip restrictions and the acceleration of Alibaba's third country infrastructure investment is not subtle. The restrictions created both the need and, by raising the cost of domestic compute alternatives, the economic justification. Huawei's trajectory runs parallel, but is architecturally different. Huawei was cut off from advanced chip supply chains earlier and more completely than most Chinese firms. Its inclusion on the Entity List in 2019 predates the broader AI chip controls. The response was a domestic semiconductor push that produced the Ascend line of AI accelerators, chips designed specifically to train and run large models without relying on Nvidia or AMD hardware. Those chips have well-documented performance gaps relative to current Nvidia products. They are also entirely outside American export control jurisdiction. A Huawei-built data center running Ascend chips in Riyadh is not subject to any American hardware restriction at any layer of the transaction. This is where the two trajectories converge into something more significant than either represents individually. The Shadow Cloud is not a single network. It is two parallel infrastructure projects, one built on legally acquired Western chips in third countries, one built on domestically produced Chinese chips deployed internationally, that together cover the gap that either alone could not. The redundancy is the point. If American regulators successfully pressure Malaysia to restrict re-export of services to Chinese entities, the Huawei-built facilities running Ascend hardware are unaffected. If domestic Chinese chip production stalls and the Ascend line fails to close the performance gap, the third country facilities running H100s remain accessible. The architecture does not have a single point of failure that American policy can target. One non-obvious historical reference applies here. The Soviet Union's technology acquisition strategy during the Cold War, detailed in the CIA's farewell dossier, declassified in the 1990s, operated on a similar distributed logic. Procurement was deliberately fragmented across multiple Western countries and corporate structures so that no single interdiction could interrupt the supply. The strategy worked until the United States coordinated with European allies to close it simultaneously. The coordination required years of diplomatic work and was never fully complete. The current situation is structurally harder. The Soviet procurement network was acquiring physical goods that moved through inspectable supply chains. The Shadow AI Cloud moves data. The enforcement surface is categorically different. What I keep coming back to is the sequencing. The export controls were announced publicly, with implementation timelines. Chinese operators had months, in some cases over a year, between the announcement of a restriction and its enforcement date. That window was used, chip orders accelerated, infrastructure deployment accelerated. By the time the controls took effect, the immediate impact was smaller than the announced policy implied because the preparation period was built into the response. Policy that announces itself before it lands gives the target time to reposition. That is not a design flaw unique to this case. It is a structural feature of how democratic governments implement trade controls. The question is whether the implementation timeline was calibrated with that reality in mind, or whether it was set for domestic political reasons that had nothing to do with enforcement effectiveness. The infrastructure that exists today suggests the latter. The strongest counterargument to this analysis runs as follows. The export controls were never intended to stop China's AI development permanently. They were intended to slow it, to introduce friction, raise costs, and preserve an American performance lead long enough for policy and industry to adapt. Measured against that more modest standard, the controls worked. China's frontier model development remains behind the American frontier. The gap has not closed as fast as it might have without any restrictions at all. This argument deserves a direct answer because it is made seriously by people who worked on the policy. The friction argument is partially correct. Costs did increase. Access to the most advanced hardware did become more complicated. Chinese AI labs operating at the frontier have faced genuine constraints that their American counterparts have not. The argument that the controls produced zero effect is not supportable. But the friction argument contains an assumption that does not hold under examination. It assumes the primary risk being managed is a performance gap, that the danger is Chinese models catching American models, and that any delay in that convergence is a policy win. That framing misses what the shadow infrastructure actually represents, which is not a performance story. It is a control story. A distributed AI compute network spanning a dozen jurisdictions, built specifically in response to American export controls, is harder to monitor, harder to sanction, and harder to shut down than a domestic Chinese AI industry would have been. The export controls did not just fail to prevent Chinese AI capability development. They changed the geographic and legal structure of that development in ways that make future intervention more difficult, not less. The friction bought time. The infrastructure built during that time made the next round of friction harder to apply. There is a second counterargument worth handling. Some analysts point to the performance limitations of the Huawei Ascend chips as evidence that the domestic alternative remains inadequate, that Chinese AI development dependent on domestically produced hardware is operating at a meaningful disadvantage that compounds over time. The most advanced Ascend chips currently available perform at roughly 60 to 70% of comparable Nvidia hardware on standard benchmarks. That gap is real. What the gap as counterargument misses is that AI model performance does not scale linearly with chip performance. Algorithmic efficiency improvements, architectural innovations, and training optimizations have repeatedly closed apparent hardware gaps faster than the hardware gap itself closed. Chinese labs have demonstrated this concretely. The DeepSeek R1 model, released in early 2025, achieved performance competitive with leading American models at a fraction of the reported training cost, using hardware configurations that would have been considered insufficient for that level of output 12 months earlier. The chip gap is a constraint. It is not a ceiling. My read on this is that Washington made a category error. The export controls were designed as if AI capability were a hardware problem, as if restricting the physical substrate would restrict the capability. But AI capability is increasingly a software, data, and algorithmic problem. Hardware is a bottleneck, not a determinant. Treating a bottleneck as a determinant produced a policy that looked comprehensive and operated narrowly. The specific data point that reframes the entire control regime is this. The Commerce Department's own assessments cited in the 2024 Bureau of Industry and Security Annual Report acknowledged that Chinese AI development continued to advance across the period of maximum restriction. The report noted progress in foundation model development, inference optimization, and deployment scale. These are not the outcomes of a successfully contained industry. The controls also produced a secondary effect that the friction argument does not account for. By restricting Chinese access to American cloud infrastructure and hardware, the policy accelerated Chinese investment in alternatives. The alternative infrastructure that now exists, the shadow cloud, the domestic chip program, the third country data center network, was not inevitable. It required capital, political will, and a clear reason to prioritize it over other investments. The export controls provided all three: containment strategies that make the contained party stronger at the thing you are trying to contain them on are not containment strategies. They are acceleration programs with extra steps. The policy achieved friction. It also achieved the conditions for something more durable than what it was trying to prevent. The implication of all of this is not that export controls are useless as a policy instrument. They work in specific conditions: when the technology is genuinely hardware dependent, when allied coordination is tight enough to close third country routes, and when the implementation timeline is short enough to preclude repositioning. None of those conditions fully held here. What Washington is now managing is not the problem the controls were designed to solve. The original problem was prevent China from acquiring advanced AI chips. That problem has been partially addressed with meaningful but incomplete effect. The problem that replaced it is structurally harder. How do you constrain an AI development program that has deliberately distributed itself across jurisdictions you do not control, built redundant infrastructure across two incompatible hardware ecosystems, and used the period of your restrictions to reduce its dependence on anything you can restrict? That is not a chip problem. It does not have a chip solution. The policy options that remain are less targeted and more disruptive than what came before. Pressuring third countries to restrict Chinese cloud service access requires those countries to accept economic costs in exchange for alignment with American strategic preferences. Some will. Malaysia, for instance, has shown responsiveness to American pressure on semiconductor-related activity within its borders. Others will not. The UAE has been explicit that its technology partnerships with Chinese firms are a sovereign commercial decision, not a security concession to negotiate away. Restricting the service layer directly, requiring American cloud providers and chip manufacturers to implement end-use monitoring on workloads running in third-country facilities, is technically feasible in narrow cases and practically unenforceable at scale. Cloud compute is fungible. A training run does not announce what it is training. The monitoring problem is not a technology problem. It is a volume problem. The remaining lever is allied chip production. If the United States, Japan, the Netherlands, and South Korea coordinate tightly enough on advanced semiconductor manufacturing, the ASML lithography machines, the TSMC fabrication capacity, the material supply chains, then the long-term hardware ceiling for Chinese AI development is lower than it would otherwise be. This is the actual logic behind the CHIPS Act and the parallel investment programs in allied countries, not to win the current round, but to maintain a production advantage that makes every future round harder for China to close. That strategy has a timeline problem. Semiconductor fabrication capacity takes years to build. The shadow cloud is operational now. The Ascend chip program is shipping hardware now. The gap between when the Allied production strategy produces results and when Chinese AI development reaches its next capability threshold is not guaranteed to work in America's favor. The honest conclusion here is that the window for hardware-based containment has likely closed. Not permanently, technology cycles and a sufficiently large performance gap between Allied and Chinese chip production could reassert hardware as the binding constraint. But that outcome requires a level of Allied coordination and implementation speed that has not been demonstrated in this policy domain. The track record is of announcements followed by slower execution than the announcements implied. What replaces containment as a strategic frame is competition. Not the rhetorical version, where competition means winning a race, but the operational version, where competition means maintaining enough of a lead across enough dimensions that the shadow infrastructure's capabilities remain a tier below what American and allied AI systems can do. That is a different problem than containment. It does not assume you can stop the other side. It assumes you cannot and plans accordingly. The shadow cloud exists. It will not be dismantled by the next round of export controls or the one after that. The facilities are legal in the jurisdictions where they operate. The services they provide are legal under current international trade frameworks. The clients they serve are not, in most cases, doing anything that existing law prohibits. What changes is the strategic posture that follows from accepting those facts rather than working around them. American AI policy spent 3 years trying to solve a hardware problem. The hardware problem was always, at best, a delay. The question that was not asked loudly enough, and what happens after the delay, is the question that needs answering now. Find a flaw in this argument. I want to see it.